Welcome to our series on sprinkler types and orientations. In this series, we talk about all the different types of fire sprinklers and orientations, their applications, and the decision-making process for what types to use across different situations. We'll learn about upright, pendant, sidewall, and specific application sprinklers, which are their own separate category, and what needs they fill in the fire protection marketplace. Mainly this module is for the discussion of the types of fire sprinklers. We'll get into characteristics like response, temperature, special coatings, and other aspects like that later. This segment will be introducing the different orientations of fire sprinklers. NFPA 13, standard for the installation of fire sprinklers, is the standard we use for most projects in most places. Other standards are used for special clients, say FM Global, FM Datasheet 2-0, installation and guidelines for sprinkler systems. These are used for people who are working on projects for clients that are insured against fire by FM Global, which is an insurance company. This standard builds on NFPA's work, but generally requires a higher level of protection than NFPA 13. The U.S. military uses a standard called UFC 3600-01, Fire Protection Engineering for Facilities. This builds on the work done by NFPA 13 and FM Global Datasheet 2-0. If your client is a military client, then this standard will be used. All these can be understood in the context of NFPA 13, so it's best to start there. So let's get started. What are the different types of fire sprinklers? Let's start with conventional sprinklers. These are very old. You may still find them in the wild. These are pendant and uprights. What I mean by that, they can be installed in either orientation, up or down. You can still find new conventional sprinklers. They're made to replace existing conventional sprinklers that are still in service. You don't find these much in action today. They're mainly found in the code book for fir vaults and very old fire sprinkler systems. Next, let's talk about standard spray sprinklers. This is the realistic starting point for most of us. The standard spray sprinkler is the quote-unquote modern sprinkler. These fire sprinklers will follow the spacing and calculation rules specified in NFPA 13. Upright and pendant sprinklers will follow the same rules for the most part. Sidewall sprinklers follow a different set of rules. This makes sense when you think about it. Upright and pendant sprinklers flow water vertically that, when shaped by a deflector, create a spray pattern that is predictable. The sidewall sprinkler flows water horizontally, and the water is also shaped by a deflector, but that water traveling horizontally needs different rules to make sure the water reaches the hazard. We also have standard spray dry sprinklers. These sprinklers have a barrel attached to the sprinkler and typically a 1-inch threaded connection at the end opposite the sprinkler. The barrel is dry, and a linkage inside opens the end, allowing water to flow through the barrel when the element on the sprinkler is broken from absorbing heat from a fire. This dry barrel allows the sprinkler to be connected to a water supply in a warm space that won't freeze, and the sprinkler can be placed in an area that will freeze, such as an outside canopy or a freezer. These sprinklers follow the same spacing and calculation rules as other standard spray sprinklers. In other words, all standard spray sprinklers follow the same rules. What are extended coverage sprinklers? Extended coverage sprinklers, you guessed it, protect more area than standard spray sprinklers. These sprinklers can be found in many different formats. We can find extended coverage residential sprinklers, light hazard sprinklers, ordinary hazard sprinklers, storage sprinklers, more on those later, and specific application sprinklers, also more on those later. We have the usual suspects, upright, pendant, sidewall, same as standard spray. Extended coverage sprinklers do have their own spacing rules, which are different than standard spray sprinklers. Their water distribution patterns are different than standard spray sprinklers, so more care has to be taken to make sure that they're spaced correctly with respect to obstructions. What are specific application storage sprinklers? Storage. Yes, storage drives a lot of what we do in fire protection. It's got several chapters dedicated to it in NFPA 13. We'll briefly walk through the sprinklers used in storage scenarios. First, we have our trusty standard spray sprinklers. What we call these are usually CMDA. This means control mode, density, area. We'll revisit this concept later. We can certainly use these sprinklers for many storage arrangements. In today's world, we have storage that stacks higher than ever, and those old standard spray sprinklers don't always keep up. Companies have introduced CMSA sprinklers to address this. This means control mode, specific application. Often these are extended coverage storage sprinklers made to control a specific hazard found in storage scenarios. They'll have their own data sheets, testing and approvals. NFPA and jurisdictions typically allow these if the installing contractor follows all the rules of the sprinkler's listing. Last, we have storage sprinklers that allow very tall storage without having sprinklers inside the racks. These are called ESFR. That's short for Early Suppression Fast Response. The philosophy of the ESFR sprinkler is to open at the very early stage of a fire, responding with a lot of water under high pressure distributed over a small area. ESFR sprinklers have their own unique way to do their hydraulic calculations, just like CMDA and CMSA. What are specific application sprinklers? Specific application sprinklers have been developed to meet some challenges that's been faced in the construction industry. I'd like to talk about attic sprinklers first. The story goes some sprinkler deflectors got smashed on the way to the testing lab, and someone said, hey, let's look at them anyways. Put them into the testing apparatus and found that the spray pattern looked like it could work under a steeply pitched roof. Now, I don't know if that story is true, but it's fun to tell. The attic sprinkler does sit under a steeply pitched roof and it sprays water down the slope of the roof. Combustible concealed space sprinklers. Some floors of buildings have interstitial space made of combustible materials. The interstitial space is the space between the ceiling of one story and the floor of the story above. By code, these spaces need fire sprinklers, or they would otherwise need some sort of expensive measures to make the area non-combustible, such as filling it full of non-combustible insulation. Thus, the interstitial sprinkler was created to meet this need. These are specific application sprinklers that meet the requirement of fire suppression while demanding less water in those spaces. Next, we have institutional sprinklers. These are tamper-resistant sprinklers. You can find these in prisons, jails, and some hospitals where people may be there for mental health reasons. MRI sprinklers. MRI machines are great tools. They can see inside your body and help doctors find illness or diagnose disease. They also have a super strong magnetic field that can rip fire sprinklers and pipe out of the ceiling. In these spaces, we'll use copper pipe and copper fire sprinklers instead and just get rid of the ferrous materials to avoid all that. In hotels, motels, houses, and other residential occupancies, we'll find residential sprinklers. These are specific application sprinklers. They do have different deflectors, and they shape water differently than other sprinklers. They have their own spacing rules too. Residential sprinklers are designed primarily to wet the walls in a compartment during a fire. What this does is it maximizes the chances of a person surviving a fire who might be in a house or inside of a dwelling unit. Window sprinklers. Current building codes require lots of different fire-resistant ratings on walls, floors, and other assemblies. Architects love to have big glass walls. Sometimes glass walls must have a fire rating. For us, this is not really a problem, but the budget people don't like that because fire-rated glass tends to be extremely expensive. One solution to this expense is the window sprinkler. These are here to give glass assembly what's equivalent to a 2-hour rating. But you must be careful and follow a very long list of rules that are required to make them work. Using these sprinklers can give architects the look they want, the cost that the owner likes, and we as engineers and technicians can sign off on it. So why use different types of fire sprinklers? Different sprinklers have been developed for different ceiling types, different hazards, different spacings, and just about any way a building can be constructed. There's literally hundreds of fire sprinklers to choose from in the marketplace. Upright sprinklers are commonly used for areas without finished ceilings. Pendent sprinklers are commonly used where a finished ceiling is present and pipe may be installed above the ceiling. And sidewall sprinklers are used where pipe may not be installed above a finished ceiling. Fire sprinklers can be mixed for an area. Uprights can be used for areas with no ceiling, pendants in areas with ceilings, and sidewalls commonly where installing pipe above an area is not an option. These sprinklers can happily be mixed provided some rules are followed. First, if there's upright sprinklers, the K-factor should be the same for the upright sprinklers. The same logic follows for pendant sprinklers and sidewall sprinklers. The K-factor should be the same among the sprinklers with the same orientation. Let's explain just one common scenario. Imagine a hotel room with a bathroom and a corridor near a hallway. The hallway is in the middle of the building. A horizontal sidewall fire sprinkler protects the sleeping room, and 1 or 2 pendant sprinklers protects the corridor and maybe the bathroom. The K-factor of the horizontal sidewall is what it needs to be to cover the room. However, the K-factor for the pendant, since it has a different orientation, it can be something different. Usually the K-factor for the horizontal sidewall will be a bit larger to cover the entire area, and the K-factor for the corridor will be smaller since it only protects a very small area. Some of this will be followed up in the hydraulic calculation modules. How many fire sprinkler models exist? There's several big companies that produce fire sprinklers. In the United States, there's some big players like Viking or Minimax, Johnson Controls, aka Tyco or Simplex, Reliable or Victaulic, to name a few. These manufacturers make hundreds of different fire sprinklers to fit all the various buildings and are made to work with all the available water supplies. All these companies have websites where you can easily filter and explore their offerings. MeyerFire also has a fire sprinkler database that lists every sprinkler we know of to be on the market today. You can access it by clicking on the toolkit at the top of the site, and you can use it to search or filter by a wide range of parameters like type, orientation, sprinkler identification number, K-factor, spacing, minimum pressure, UL listing, all kinds of filters so you can see what's on the market and get links to product data on each manufacturer's site quickly. That's included with this platform. So what kind of fire sprinklers exist? Fire sprinkler systems include conventional, standard spray, extended coverage, specific storage like CMDA, CMSA, ESFR, as well as specific application sprinklers such as attic, interstitial, institutional, MRI, residential, and window sprinklers, all designed each for a unique fire protection need. In our next segment, we'll expand on the decision-making process for using different types of sprinklers. I'm Max Newton, and this is MeyerFire University.
This has been a preview of MeyerFire University. Join the next generation of fire protection experts at www.meyerfireuniversity.com.